because it did not get. Okay, so good morning, everyone. Today is our third session with SUNREF. Today is the third and final session with SUNREF 2 technical team project. It will be about energy efficiency in buildings. Let me introduce our two speakers today. Amandine Gal, who is the key international technical expert for SUNREF Palestine 2. She's a principal advisor at Econlair. And Julia, I could not pronounce the last name.
D'Angiolini.
What?
D'Angiolini.
Okay, D'Angiolini. She's a principal advisor for sustainable energy at Econlair as well. So thanks everybody for your time and for attending. And I will leave the floor to Rahaf and the speakers to start.
Okay, hello everyone. I will be sending you all the recording, the presentation material if I get access to it, and the contacts of Amandine and Julia. And if you have any question after the session, you can contact us and we will provide you the information you need.
Thank you. So Julia, can you start sharing thank you. Hi, everybody. I'm very pleased to be here with you and Julia. And I'd like to thank very much Green Building Council for organizing this session. So Julia and I are part of Econlair. We are the technical assistants for the SUNREF 2 project. And today we will talk about energy efficiency in building. But firstly, I'd like to present shortly what it is SUNREF 2 and the focus, and then we'll continue talking specifically on today's topic. So SUNREF, it's a new credit line of $55 million that was launched last spring. Its part is that you have an investment grant and a TA support that is also available for 11 million. But in this case, it's euro. The partnership, it's the funding comes from the European Commission and Proparco, which is the French development agency, and the two banks that are developing and offering this credit line are Bank of Palestine, Karaman Bank. And you have also two affiliated Islamic partners, SAFA and EAB. One thing I'd like to point, it's like the SUNREF. Unfortunately, it's only for private sector. So I know here that we have people from the public or para-public sector, and it's not at the focus of the credit line. It's mainly SMEs. So the idea is to help SMEs to develop sustainable energy project in Palestine. Compared to for the people that know SUNREF 1, now we have a new shift toward energy efficiency. The idea is to push energy efficiency either in building, in industry, in all sectors, to develop more energy efficiency projects. And within SUNREF, we have two different levels of energy efficiency, which give a different subsidy. One is high energy efficiency. It's what we try to push as much as possible. It's about retrofit and replacement of equipment. And today, Julia and I will present you which kind of energy efficiency measure you can implement that would go to this high energy efficiency subsidy. And the medium efficiency, it's like the best available technology or more efficient for new projects. The duration of the credit line is 8 years, and the disbursement should be made by next year, September. So we still have 1 year or so. Julia. Thank you. So the main criteria that we have regarding the energy efficiency, it's like we need to have a 20% reduction of energy consumption or a 20% less energy per unit of production or 20% of reduction in GHG emission for fuel switching projects. Also some class A household appliances, we are hopefully launching soon an activity in relation with Sbitani to sell, to have some premium and some subsidy for refrigerator, class A refrigerator, so to for as equipment of households. And yeah, mainly it's the criteria that we have. Now I'd like to talk to you about something that is really important. It's a study fund. So it's a fund. There are funds that are available for analysis, energy audit, feasibility analysis, design, mainly for energy efficiency projects. This has been accepted like recently from Proparco and the European Commission. So the idea, it's the client and the people that have building, industry, so on, that need some help to define a project, have this fund available up to 40,000 euro per project. It might cover all the costs depending on the type of analysis. And it's not on the slide, but I'd like to tell you for the people that here, shortly we will be launching a call for experts. So if you know people, or if you yourself are interested to be one of the experts that we can reach to develop this kind of project analysis, please reach me or reach Econolaire people. So we will put you on the list. We will ask you some like experience, credential, CV to make sure that we understand what is your experience and on which project, which analysis you suit better. But the idea is really to have a list of experts and then to be able to launch tenders for this small analysis. And so the local expert will be able to send a very short proposal, and we'll select on this proposal. And the overall idea is, of course, to help the ecosystem of energy efficiency and sustainable energy, to help develop also the expertise of the local engineers and consulting company and engineering company. So now I give the floor to Julia. She will go through mainly architectural improvement in energy efficiency in building. And then I will talk again about more mechanical and electrical system.
Yes, thank you, Amandine. So I think I will present this part of, as Amandine mentioned, architectural measures for energy efficiency in buildings. Then we can probably have a break of 10 minutes when we can also use for questions, and then Amandine will take again the floor for the appliances. So let's start. So now I'm going to dive in on the real energy efficiency in buildings. So first, I wanted just to provide you with a couple of information on what is the typical consumption profile in your country. So here, this is the data that came from the World Bank based on audits. It's actually from 2014, so it's not really recent, but it's the most recent we could find. But I think it still responds to what is the actual profiling in the country. So you can see about the commercial and public services sector consumption. that you have. It's the breakdown is divided in hospital, hotel administration, public services, and healthcare, and then you can see the different appliances that contributes to the level of consumption. So as you can see, lighting is dominant, and then you have also refrigerators and in a small part in the hotel, and then you have chiller that is relevant, for example, in the hotel, and then the others like AC that is really relevant in most sectors, and a little bit of compressors and pumps, and then the others. So for sure, lighting is one of the most, together with the cooling appliances. And the typical, let's say, best practice is to getting right from the beginning of a building project. That means that even when you, and we'll go through much more on the different steps and the sequences of actions that you have to do when you have in mind to retrofit or build a new construction. But the appliances is as we have seen in the profile, it's very important, especially based on what is the typical lifetime of energy consuming building stock and equipment. So when you look at the different component in a building, you can see that, for example, the building stock at the beginning of the line, it stands for several years. So the lifetime of construction is the longest actually in the infrastructure related to living, and it really means that it has to be built in an efficient way if you don't want to lose energy during its lifetimes. Then you have power station, electric transmission, distribution, telecom pipelines, and you can see also residential space, heating and cooling equipment as a pretty good lifetime. You can also see light bulbs, but here there is not LED, but well, you can see the difference from incandescent and fluorescent. So fluorescent is as a longer lifetime, LED even more. So it's really necessary to consider the lifetime of equipment that you will choose for your building. Energy efficient buildings are designed to significantly reduce heating and cooling energy needs. Is a kind of skin, a second skin of your body, and regardless of the type of energy and the type of heating or cooling equipment. So the aim is to build and with a high performance and comfort and property value, and reduce the energy consumption and also the maintenance of the building. Here we present a nice roadmap to design energy efficiency in buildings. As you can see on the left side of the slide, there is this green square called optimum bioclimatic design. Bioclimatic is a term that is now becoming again very usual in the construction world. The bioclimatic architecture it takes into account the climate environmental conditions of okay. I see there are a few messages. I don't know if there is
Not yet. We were just encouraging them to add their questions or inquiries, just in case. So they
Okay, no problem.
So please keep your for the participants. Please keep yourself muted until you ask for it. Yalla, bye.
So I was saying bioclimatic architecture takes into account what is the climate and environmental conditions of the site where you are building or retrofitting a building. And this is to help achieving thermal and visual comfort inside the building. The bioclimatic design takes also into account the local climate to make the best possible use of what is the solar energy available in the site, and also other environmental sources, even water, even any other, for example, geothermal energy or any other sources that are available in your site, rather than working against them. Thermal insulation is for sure the low cost, widely and also widely available, and also proven technology that can really save energy and money, and also can reduce emissions when it's installed. So going in the different phases of what it means building a bioclimatic construction, and so what is bioclimatic design. Firstly, we go with the insulation and the earth thickness that is the measure to reduce the air leakage. So it can really block the uncontrolled flow of air through the shape of your building, and that can for sure reduce the performance of heating and cooling your own construction. And then we have the ventilation at the third place, that is intended much more as a controlled ingress and egress of air through your construction. So that allows delivering fresh air, but also exhausting stale air through the ventilators, or in combination with other designed heating system. And we'll see all the different typology of ventilation that can be conceived in a bioclimatic design. And then we go with the equipment, and then we go with the renewable energy. This is really the sequences of elements that allow any constructor to conceive a bioclimatic design for building. So for sure, the benefit at maximum, it's from sun radiation. So at the top, we have the performance of the envelope that allow to reducing heat loss, and also ensure summer comfort, because it also depends on the country, but it's pretty much your case. And then the air quality for fresh and healthy air, but also moisture management. So it blocks thermal bridge, and so moisture creation, for example, in the corner of the walls on the top of your ceiling. And then optimize the equipment with good control and regulation, and for sure adapt to local condition the renewable sources that became an additional element of your performance construction. Related actions are, for example, to shape and orient your building, orient and ensure of the glazing, so all the openings and the windows, and also shading and wind protection. A good insulation of the entire envelope of your construction. It includes floor, walls, roof, and windows and doors as well. So as we say, to block the thermal bridges, and also to control the air tightness. And the ventilation, so always recommended a double floor variable, but we'll see later the different typologies. The ground heat exchanger, and also for equipment, higher efficient gas boiler, heat pumps, solar collectors, and ACs for sure, refrigerators, lighting. That it's not mentioned, but as we've seen in the country, is one of the most consuming technology. And then for the renewable energy, photovoltaic, wind power, and biomass. So let's go step by step into this huge scheme and see also what are the benefits of an energy efficient buildings. Probably you all know the impacts and the effects of building energy efficient construction. But we wanted to highlight the most relevant. Buildings are for sure attractive long-term investment. As we have seen, they have the longest lifetimes into the infrastructure of living, and they can last more than 40 years. We have many examples of buildings older than 40. Efficient buildings provide better social and financial returns. The construction sector represents 10% of the world GDP and 10% of the workforce, and creates more jobs than any other sectoral investment. 1 million invested in energy efficiency measures create between 8 and 27 jobs per year. And low operating cost building may be also easier to sell or to rent. That's for sure. Building efficiency is one of the most affordable ways to mitigate climate change. Energy efficiency investment in buildings provide a huge return on investment and have high emission reduction impacts per dollar investment. And I wanted to add something that is not written here, but actually retrofitting is also very relevant about the sentence that we say it's most affordable ways to mitigate climate change, because as we said, the buildings last for years, for more than 40 years. So retrofitting a building is also a way to maintain this building and make it more efficient, but also mitigate the impacts that can have on the environment and on the energy use as well, building a new construction, because all the energy required and the emissions that are produced when we build a new building is much higher than retrofitting an existing one. Building efficiency can also significantly increase living comfort and health conditions, and particularly in the most vulnerable places. Energy efficient buildings reduce air pollution and related illnesses as well, increasing comfort and saving financial and social costs. There are thousands of studies demonstrating that an energy efficient building also creates a sane and comfortable environment in the house, and that also helps reducing drastically and dramatically the illness created from the indoor air pollution. And we generally say that this is the lock-in effect. It means that including energy efficiency measures at the planning stages offers the best cost impact ratio over the building life cycle. This is for sure, it's much more related to new construction, because it's really about, sorry? Okay, it's really about conceiving and designing a building, considering energy efficiency since the beginning, the first stage of the construction and the design, for sure. But it also it is also valid for what is retrofitting, in the sense that when you go for projects in the retrofitting of buildings, you can definitely create your life cycle costs and or as represented in the graph, and already determine what will be your savings, and based on what will be your energy efficiency measures and investments at the beginning. So that it will allow you to define what priority measures, energy efficiency measures, will be implemented at the beginning, and then what kind of impacts in terms of savings, energy savings, and cost will have in the short, medium, and long terms. And that is also a practice that people use in the retrofitting, that can allow them to plan different measures in different timelines to reach the highest savings potential. So that's why it's energy efficiency is a lock-in effect, because it can really change the life time of your construction. Those are the energy efficient design principles. We call it the trias energetica, that is organized in three main steps that are at the basis, like as necessary measures, is the minimization of energy needs with the appropriate building design, so bioclimatic or passive. And we can talk about both and the differences. And the second step, it's design or considering including energy efficiency technologies for HVAC, and also reducing remaining energy needed for heating, cooling, or lighting. And at the third step, the use of renewable energy sources. So it's really necessary to define a planning strategy which focuses on creating a low energy, comfortable building that is not simply a normal building in which renewable energy is used or installed, but it has to be designed by really doing the maximum effort by minimizing the amount of energy needed into the building. So before you minimize, then you add help for energy, and then you finalize with the renewable sources. And is there anyone that wants to jump in for question?
You want to open it for questions now?
No, I think I can.
No, I
continue,
think
but...
we should go until the end and open it for question at the end.
Okay.
Julia, I think it's better.
Okay. So as I said at the beginning, the climate and the weather conditions are significant elements for designing a bioclimatic architecture. Climate is really described as the average course or condition of the weather in a place, in a country where you're building your construction, and usually over a period of years, so that you can have kind of map of the temperature, the wind velocity, and frequency of precipitation and humidity. And the shelter or building is normally designed to protect the occupants, as I say, as a second skin. So it also means that has to protect the occupants from the conditions of the weather. That's why the climate is the first element to be considered when you conceive your building. Generally, the way buildings are planned and designed today have direct implication on the energy consumption, but it can also they can also impact your everyday life in the sense of the comfort, but also in the sense of your environment and your energy bills, for sure. So their contribution on the climate change is very important. Here we put the map that is it is published in the website of the UNDP, but I think it was created under the World Bank project. So you can see what is the climate classification of Palestine, the mostly arid or hyper-arid or extremely arid and semi-arid areas, and then you have a central subhumid area, and you will see in the next slides how those different conditions can be addressed to ensure comfort of your building only through construction, architectural, let's say, measures. So let's go through what is bioclimatic passive building design. We'll see what's the difference. Passive design reduces or eliminates the need for auxiliary heating or cooling. So it means that, as I said in the first slide, the second and only the second step is considering appliances for your comfort. So the term passive design refers to building whose normally architectural features are such that they take advantage of local conditions and resources to provide an indoor environment that is much comfortable as possible and reduce the energy consumption. And it's also called the solar architecture. Solar, not when we say solar, we always think about PV, but no, it's solar in the sense that it's conceived considering the availability of resources as sun, and it can be classified as passive or active. It really depends on the technologies and techniques that are used for the solar collection. Solar passive is also a term applied to building where solar radiation enters the interior space and for sure through the openings, the windows. Solar active refers to building where solar thermal collectors are also added to the building itself, to the envelope, let's say. So bioclimatic building design, it includes, as you can see in the drawings, in these nice schemes, a suitable building shape that is the form and also the grade of compactness, and also the orientation that has to maximize or minimize the solar gains. It depends on the climate condition. An adequate thermal mass of the envelope, a suitable roof design. Here in the drawing you see you know, kind of kids design of roof, but the roof can be really designed as to respond to the needs of comfort in the site you're building. Light color or reflective coatings on roof and facades to reduce solar heat gains. That really depends again on the conditions, and the appropriate design and positioning of windows and openings in general, and also natural ventilation systems. So firstly, but that's much related to this to new building, but firstly you go for a site analysis. Actually, the site analysis is also related to retrofitting, because if you want to apply energy efficiency measures and you want to use what is resources around your site, you have to analyze the site as well. So what we look at, firstly, we look at the SUNPAT to orient the building, minimizing thermal loads. This is when you do new construction. Prevailing winds, that speed and direction of the prevailing winds to make use of natural ventilation, and also avoiding overrun of mechanical equipment. That can also be done when you're doing retrofitting, actually, because if you need to include protection, wind protection, also if you want to make additional natural ventilation techniques in your building during the retrofitting phase, you have to analyze it. Then the site topography, that is the presence of rivers, streams, valleys, hills, mountains, to take advantage of natural resources and shadow. And then analysis of the vegetation that help regulating temperature and dust reduction in urban areas. So those are the 4 elements when you do a site analysis. Then you go, you dive in your site. So you conduct a site plan that allow for solar access during the cold season of the year, but also adequate sun protection and ventilation during the warm season, and that allow to decreasing the overall energy demand of a building. What you have to look at, firstly, the building orientation. The main facade should face either north or south to limit the need for cooling. The building position that allows for use of natural light, decreasing need for artificial lighting. And then the building footprint. Normally it should be less than 50% of the total plot area. This is also based on the national or even local regulation that you have in your country. Compactness increases the efficiency as it has a smaller dispersing surface per unit of usable space, especially in your climate. So first, as mentioned, you have to consider the building shape and orientation. The capability of a building to store or release heat is related to its volume and also to its mass and shape, since losses or gains take place through its surface. So building shapes and orientation are the first choices in the design process, and they are very critical because they have the most impact on thermal and visual comfort, and also for sure on the energy consumption. So on the figure, you can see that reducing the surface to volume, so the ratio S and V on V, also reduces the amount of material needed to make the envelope, with for sure also lower the construction costs, but also the GHG emission and the impacts, because you will also reduce the energy grid. And so a smaller amount of embodied energy for the construction. On the other end, for the purpose of natural lighting and natural ventilation, a long, narrow shape is better than a square one. as you can see here, there are a couple of examples just to show you the ratio, and you can see that the narrow shape is better. For example, here we just put a couple of examples, the building that are narrow and that can achieve the maximum of natural lighting penetration, and also the best flow for natural ventilation, minimizing the heat gain. So on the right side, you see this is typical. This is a construction, actually, a bioclimatic construction made in a hot, arid area, and this is a compact shape, as you can see. That, you know, the daily temperature in this kind of area, in the hot arid, the swing of the daily temperature is very high. You have hot days and cool nights. So the compact shape is best because it provides less low surface to volume ratio, but also minimize the area of envelope exposed to the sun, so that allows to maintain the kind of flat temperature inside. By contrast, in the hot, humid areas on the left side of the screen, you have a different construction, because you also have different temperature swing that is very small, and where the humidity, so the range of temperature are very, very short, and the humidity is actually very high. So the shape has to be open, much open as possible to allow natural ventilation. But also you need to protect the envelope from the sun. So sun protection is definitely essential. And all possible measures should be taken to provide it. Here there are these nice solar shading, but there are many different solutions that we will show you. So building orientation, as we say, is very critical, and the basic rule depends on the climate conditions of the building site, and correctly orienting a building doesn't cost anything. So from the beginning, it's the first measure that will save a lot of money and a lot of energy for the future. Generally, in hot climates, the basic rule is to minimize facades facing east and west, and taking into account local prevailing winds because of their connection with the natural ventilation. So as you see here, there is a scheme on the left side. This is a scheme of the pathway, of the sun pathway. So this is the way you orient your building, as we say, the long shape, but minimize the exposure to the west and east facing, because in the east, on the east and on the west orientation, you have the peak of heating from the sun. And then the orientation according to the wind, as you see here, is at 90 degrees, is at 45, and you can, it really depends on what you need for your building. But in the two different figures, you have 90 degrees, you have a certain flow of wind that can be used. At 45, you have much more wind that can be used, natural ventilation that can be used to ensure ventilation of your building, and also minimize the moisture of walls inside. The thermal envelope is for sure the second step when you design your building. And here again, you can do the difference without additional cost. So the envelope includes the walls, the thermal mass and the insulation, the roof, the openings and windows, solar shading, and natural ventilation. So let's see all of them. I start with the walls. Walls constitute the major part of the building envelope. Is the most extensive. A wall which is not protected from the sun, it's up very fast and transmits it to the inside. So the thickness and material of a wall can really vary the performance of your building and the capacity to control the heat gain. The resistance to the heat flow through the exposed walls can be increased by different measures. One is increasing the thickness of the wall, adapt cavity wall construction, use walls made of suitable heat insulating material, fix the heat insulating material on the inside or outside of the exposed wall, use radiant barriers, and apply light color whitewash on the exposed side of the wall. So for sure, I said increase the thickness of the wall, but this is really depends on the material that you're using to build your construction. The wall insulation, it's part of the thickness of the wall, and the use of multi-layered construction can be considered especially for the east and west facing walls. But generally it really depends on the cost analysis of your project. And also when you do retrofitting, it really depends on what are the investments that you can face for retrofitting. For sure, insulation is one of the best measures that you can do when you consider retrofitting a non-performant building. Then the thermal mass of walls. This is much difficult, let's say, in retrofitting, but it really counts. It's not the mass, but the combination of the mass and the thermal resistance of the material you use for your walls, like bricks, cement, earth walls. Provide thermal mass, which also adds to energy efficiency by slowing heat transferred from the exterior to the interior. But they can also be efficiently used in hot, humid areas. If it depends on the thickness that is designed. And on
Julia, excuse me, we still have like 15-20 minutes, so can you, if we want to advance and let the time the people to have questions. Sorry for this. Sorry.
No problem. And then let's go. So, well, as I say, thermal insulation refers to the insulation materials to slow down and control the heat. And the thermal mass is really about the specific material ability to absorb and store and then radiate the heat internally in the building. Just to so Amandine, we have 10 minutes before the break.
We are not doing any break. We just follow up, and because we need to finish in like 30-35 minutes, no more. So we
So-
still have, we want to have time for the people to take questions. And
Sure. So I'm going to run a bit here, but then I can also respond on questions by email. So as I said at the beginning of the presentation of the envelope, the roof is part of a building, of the building envelope, and this part is the part that received the most solar radiation. So the first prerequisite when you design your envelope after the walls is to design a high reflective surface to minimize the amount of solar energy absorbed. As you can see here, there are different ways to design a roof. It depends on your climate conditions and also the needs you have for the performance of your building. To keep a roof cool, they should be sloped towards the prevailing breeze, and also any kind of obstruction that will prevent the airflow along the roof surface should be avoided. So be careful about also the presence and the orientation of the vegetation around your building. Again, that measures doesn't have additional costs, and also when doing retrofitting, consider the insulation of the roof is if it's not appropriate since the beginning of your building. Then the openings, as they are part of the envelope, 40% of the unwanted heat and unnecessary heat that comes in the building generally comes through the windows, and their protection from the sun is definitely imperative. So the best wall ratio, especially in your climate, is 0.203. That is acceptable. That is the ratio between the wall and the window. The openings should be placed on the north and on the south facing walls for sure. Principally, it doesn't mean that you don't have to put openings on the east-west, but you have to properly protect them. Larger openings should be placed on the north-facing walls in the south hemisphere, and on the south-facing walls in the north hemisphere. And openings should also be avoided on the east and facing, but doesn't mean that you cannot. It's nice to have double exposure in a building, definitely. But you really need to put solar shading, and also the window, the frame of the window has to be properly designed in the sense, and the material has to be properly chosen to avoid and to reduce thermal bridges in your building. For solar shading, as mentioned, the designer have to be aware of the path of the sun at the site, the sun elevations of different days, and the azimuth angles through each day of the year. So you have to use different system depending on the walls, on the orientation of the walls, and depending also on what are the needs of your comfort of your building. Here are some examples of solar shading. So the horizontal, like this is very good because it protects your windows completely. This is not good because it lets sun radiations enters. And here are other. Vertical is also possible. Egg, it's also used, especially in countries where climate is similar to yours. So yeah. And then natural ventilation is the process that I started mentioning at the beginning. It's part of the first element of the trias energetica. This is the process of drawing in fresh air and discharging waste air from an indoor space. So or when you conceive your building, you really need to understand how the flow from outside, based on the analysis of the site plan, can be used to refresh your building and just let out its air. And it uses the airflow caused by pressure difference between the building and its surrounding. The building acts actually as a chimney. So the design is not that difficult. Natural ventilation can be cross ventilation through a single banquet room, can be also ventilation through circulation in different rooms, can be also, you know, like the third drawings on the right, that can from external projections of the airflow patterns. You see here is a single exposure of openings. You can also have to avoid the stack effect, of course, when there is a difference between the inside and outside temperatures that is brought by warm air rising and escaping through high level outlets, and thus drawing in colder, heavier air from outside. So for example, this kind of design you can find in different countries, but also in ancient actually methods of architecture in your geographic area. You want to jump in?
Yeah.
Amandine?
So yeah, Julia explained very clearly the importance of passive design. I think it's sincerely one of the best things to do when you think even in a very modern building. Try to put as much as possible like passive design. We have not go through, but there is many ways to do double facade. Very interesting way to use the sun and the wind to really accommodate your building, and so the building will be will have less impact from the outside temperature, but still we need some mechanical system. So now we will dive into the mechanical system and the electrical system to supply and to make the building comfortable, to make the building livable, to make the building usable. And so just here, this is very interesting slide that show you that the lifetime of a building, in this case it was 30 years, but I think, Julia, we talk more about 40 years in general. But the majority of the costs related to the building is during its operation and support. It's not during the design at the beginning, or even if you think in a retrofit, it's not exactly at this stage. So we really would like to see that, to show you that the importance in the pie chart, the importance of the cooling, especially in your country, and sometimes, of course, the heating, but you have also appliances, lighting, hot water, that have a huge impact in the cost of the building. And so there is many ways to reduce energy consumption in also the technical part of the building. Julia. Thank you. So if we talk about residential, which is what we usually think and take as a first example, because it's one of the easy. The energy efficient building are designed in general to reduce heating and cooling energy needs. Okay, so the step that Julia described, it's very important to remind. But first you think of bioclimatic architecture, then you think about high performance building envelope, then high performance appliance and equipment, and until at the end renewable sources. It's really something that we would like to think for you to have in mind, that the first step would be to reduce energy consumption, and then you supply with renewable sources. Okay. Thank you. So the lighting technology, it's one of the easiest way to do energy efficiency, because first of all, it's easy to implement. It's not very complicating from a technical point of view, and the cost is quite limited also. But you have to think that the lighting accounts up to 30% of household electricity cost, and in the case of office building or commercial building or hospital, it might not be 30%, because you have all the ventilation system and all the cooling and so on. That takes a lot of energy, but still it's a significant amount of the energy consumption of the building. And just upgrading with new energy efficient lighting system can reduce easily by 50%. And if we add also like lighting controls with sensor for adapting the light or the occupancy, like for instance in corridors where you don't have nobody, it's not necessarily to be to have light on, and when someone arrives it's pop up, so it's occupancy sensor. But also you have other sensors that measures the light into the zone and adjust the lighting technology to with maybe dims to the need in terms of lux. So really really thinking of LED, it's and as Julia mentioned, it's not only about energy efficiency per se, because it gives a higher lumen per watt, so it reduces the watt and it's very good efficiency, but it's also a lifetime thing. And in this particular case, the lighting, it's something that it's clear that LED are better in terms of efficiency and lifetime. Thank you. Regarding refrigerator, as I told you, maybe with SUNREF, hopefully we are working hard to make some subsidy for the Palestinian household to get some for buying new high energy efficient refrigerator. But you have to understand that currently the refrigerators that have a level A consume way more or less energy than the refrigerators that have a level B or C. The level B or C, I can show you, it's from Palestine. I don't know if you can see. This is a level that you have in your own refrigerator. It's something, it's half
Your
in
screen
Arabic,
is
half in
not clear,
English.
so if you can.
Yeah, sorry, I don't know, but it's, I think I can send it. But it's really interesting. And if you have also a bigger volume, it will need more energy consumption. So it's very important to adapt the size of your refrigerator and the size of all your equipment to your needs. Now we arrive with this new big refrigerator because it comes from the US, but maybe you don't need so huge refrigerator, and so you will be able to reduce energy consumption thanks to adapting the size of your refrigerator. Julia, can you? Thank you so much. So talking about also something that it's widely used in Palestine, it's the room air conditioner. The room air conditioner are not only used in residential building, but also in office building. And how we measure the efficiency, it's using the COP, the coefficient of performance. So the coefficient of performance is a power output divided by the power input. And it's above, it's not in percentage, as other efficiency parameters, but in this case it's a number. So in this case we can see quite easily, and I know it's quite widely common now to have inverter split air conditioner which have a higher COP. Higher COP mean higher energy efficiency, but still it's something that I want particularly to relate to passive building, because the need of air conditioner, of course, due to global warming, and it's not very nice to be 35 degrees in your house. So I think it's very important to have a room air conditioner to have a comfortable indoor environment. But it is really important to first decrease the energy demands thanks to passive system, and then to install a system that fits the demands and it's not too big and it's not running all the time. So it's my main point. And there is many possibility of energy saving in air conditioning. So it's a summary of possible energy efficiency gain by the different component of, but it's more related to not room air conditioner, but the air conditioning system that are installed in commercial building, office buildings, so on. So you can have high efficiency heat exchanger. The savings can go up to from 9% to around 30%. This is how you have to understand these numbers. And if you have higher efficiency compressor, again, you save in percentage. And then motor with variable speed drive to adapt to the demand. Also you save. And then you have electronic controls that reduce standby load. And at the end, thanks to all of this, you can improve your air conditioning system, the efficiency of it from 60 to 72%. It's huge. So it's really important to have a look to your system and to be able to give some analysis, to do some analysis and analyze how much your air conditioning system is consuming currently, and by using this energy efficiency measure, how much can we save? Because these are not so complicated energy efficiency measure to be installed, and neither to be designed. So it's a very good way to reduce your energy consumption in the building. Now, when we talk about commercial building, we have more huge HVAC system. So the HVAC system include a large variety of active technology, and they are designed to provide similar comfort and also, very important, appropriate air quality in an enclosed space. So air quality, it's very important, and of course you need to design the system and operate the system to have a good air quality. It's not only a good temperature, but it's also a good air quality. So HVAC system, they occupy some part in your building, so it's have a cost related to this. They constitute an important part of the budget for the construction and a huge part of the operational cost of your building. Okay, so it's important to think of the HVAC system as a whole system. It have a huge impact, and it's important to understand that many easy energy efficiency measure can improve drastically the energy consumption of your HVAC system, from the consumption part, like the supply part, which is a compressor or the motor, but up to the fan and to the distribution system with the grid of air. Like, just for instance, just a quick note on this, just where the thermostats are located can greatly impact the energy consumption of your system. So it's not something very complicated to change the location of the thermostat. But if the thermostats are not located in a good place, the system is not working properly. So it can have an impact. So just simple energy efficiency measure can be done. And now we'll talk about what is the potential for energy saving in HVAC system. So we talk generally about seasonal energy efficiency ratio that consider variation of temperature and along the year. the COP that we saw before, it's static. It does not take into account the temperature and how the system is working. The SEER is taking into account the temperature along the year. So in this case, we can see that there is, the higher the CR, the greater are the savings. The CR, it's calculated by the, it's calculated, usually you have it in laboratory, and it's made it, and they make vary the temperature, outside temperature, because the system, it's not responding the same depending the outside temperature that you have. So it's important to see that if you have a SER like a smaller one, which means a lower efficiency, you can gain just with the system, not even using it, not even taking into account passive architecture, you can save by more than 50% of your consumption just by using high efficient system. Now the impact of efficient building and HVAC system on cooling demand. So we wanted to show you these two graphs that are, for me, really impacting, especially from the residential part and the commercial part, because these are examples that were developed by the US Ministry of Energy, the Department of Energy, that shows that the lighting here, if we talk only about commercial building, the lighting can greatly decrease the energy consumption of a building if you just implement like easy controlling or easy replacement of a lighting system to LED. Also, if you have better windows, have a huge impact, because generally in commercial building, you have a huge window facade, and part of the facade is glazed. So it have a huge impact. And then just for HVAC system, you see that combining both, it also give you a huge impact. Meaning that the total energy saving, if you implement such measure only on lighting, window, and HVAC, we are not talking about all the insulation of roof and so on, but just taking this, it can, if you use the best available efficiency system that it is in the market, you can have around 80% of energy saving, which is huge. And if we talk about residential, also you see that the primary energy unit intensity is lower, but still you can have nice energy saving. But in this case, having a more global approach and comprehensive approach, but reaching more than 50%. Now I'd like to talk about air, fresh air and air quality. It is very important to have controlled ventilation especially in hospitals or in commercial building, because it have a huge impact on the health of the occupant, and also if we are talking about commercial building and office building, productivity of the people working in this. There is many many study about it. There is a norm that it's widely used, and the European norm even is based on this, is the ASHRAE 52.1, where it defines a level of ventilation needed depending on the occupation and the type of building. Then if we talk about ventilation, there is huge way to, Julia. There is huge way to reduce the energy consumption thanks to ventilation. So it's using heat recovery. There is a wide variety of heat recovery system. The one that we see here, it's a plaque system. but we can have wheels, you can have other heat exchanger, and this recovery allows to have, even if you have a high outside air demand, because it's a very occupied building or it's a hospital, you can still save energy and by using this heat exchanger to preheat or pre-cool the outside air that is coming into your building. It tends to be the system might be have a wide variety of efficiency, but still it's very good to have it because it's help reducing greatly the HVAC consumption. And this is a example of the heat recovery via heat wheel that have a higher efficiency than the plagues that we have seen before. The plague are widely used mainly in Europe in a residential building, and the heat recovery via heat wheel are more commonly used into building with large rooftop package unit or air handling unit, so more in the commercial sector or tertiary sector. Also, one thing that is very important and an easy way to reduce the consumption, energy consumption related to ventilation, it's to use what we call economizer cycle. It's when the outdoor air it's cooler than the cooling set point to the temperature. And so it's happened generally mainly in the office in commercial building, because commercial building has huge internal charge. So there is a lot of heat that is produced within the building due to occupation and also lighting system and our computers, a printer, coffee machine, whatever, they produce heat. And so in the setup temperature, it can be like 17 outside, and inside it can be 23. Also due to the sun, the windows, the radiation. So you can easily, instead of using the air conditioning, just use the outside air, which is cooler, just put more outside air within your building, so you will save energy. You don't have to use the air conditioning system. Now we need control to control of the system. Buildings are getting more and more complicated. The system are getting more and more advanced, and there is many type of controls that you can use. You have the most easiest one, which are the on-off switches that I'm sure in Palestine everywhere it exists, but we have seen example that if for lighting system in some countries they didn't have even on-off switches, so it can happen. You can have dimmers that also helps a lot for mainly for lighting system, and for hydraulic system it's called a valve, like really on off. But after we have a lot of automatic system with timer, dimmer with photo sensor for lighting, some thermostat that is widely used, and so they can be integrated into the building automation system. So building automation system doesn't need to be complicated to work, doesn't need to have CO2, CO, like here we can see that everything is connected, like also for the fire, for the security, for the braking, but it doesn't need to be so complicated. It can be kind of more easy to maneuver, more easy to operate, but still very functioning. But the sensor need to be placed at the right place, need to use correctly by the operator, and some maintenance also need to be performed correctly on this sensor, because they tend to deviate by the time and not measure correctly. So some preventive maintenance is also needed. So that energy saving strategy related to control, I put some example here. We have the economizers that I already said. We have chilled water reset. When you reset the chilled water temperature, depending on the cooling load of the building, you just adapt the temperature of the system if it's a highly occupied or lower occupied moment of the building. You have the same thing with the hot water. You can also optimize start and stop because sometimes it's less energy consuming. You just stop before the end of the day, and it has a nice curve for instance it's read slowly, so you can still stop the system and the indoor environment is still comfortable. So there is many ways to work with the control system to reduce and to have energy saving. So the key takeaway for today are generally, first thing, bioclimatic passive system. They could reduce operational cost by 20 to 50% throughout their life cycle. And I would say for very nice building, passive building, it can even go higher, really, than 50%. This system can avoid completely the use of heating, cooling, and even ventilation system if you design it correctly. When you do your retrofit of your building project, please use the best quality and performance technology available in the market, because as you have seen in different slides, you can gain really a lot of energy by 20% just by choosing a level A standard or instead of a level B, and its impact directly in your operation costs. And so it's taking into account the payback of the system. You really want to choose the best technology available. And something that Julia mentioned it at the beginning, that it's really important. We have this locking effect in the building. Building are long-term, they have a long lifetime, mainly around, I don't know how much you say, Julia, but 40 years usually we use, more than 30 years, 50 years.
More than 40.
Yeah, so when you design if we talk about retrofits, think long-term. Do not think like short-term as maybe a car or other equipment. Buildings are here for a long time, so it can be very good to have a more like long-term thinking. Thank you so much.
Okay, so are we now going to open the questions? Anyone would like to ask Amandine or Julia a question? Please raise your hand using reactions.
Maybe Julia, we can stop sharing. Yeah.
أي حدا بحب يسأل سؤال يرفع إيده عشان يحكي. Okay.
Karim?
كريم تفضل.
Yes, but start. Thank you for the presentation. And I had two questions. Initially, for the study fund, where can we get more information in regards to that?
Just be in contact with Econolaire, so or me or Marco Markov, your colleague have his name, so do not hesitate to contact us regarding this. So now we are in a phase that we do not have project, but we are in a phase that we need to have a list of experts to after be able to propose them the project. So it will be open shortlist called. So the client and us together, we will be able to choose the best suited engineering company or consultant for this type of project. So if you are a consultant in engineering and you're bringing us a project for the study funds, it might be possible that you will not be assigned to this project. It's a possibility. So, but yeah, we're now looking for experts. We will shortly launch a call and we will send for sure the link via the Green Building Council. So they will be able to share with their members, and it will be very interesting to have as much as possible energy efficiency experts, especially energy efficiency experts in Palestine, to be able to deliver some nice analysis. Yeah.
Okay, right. And then secondly, in regards to energy efficiency, where do electric vehicle stations fall into place within this?
Julia?
Related to the constructions, from my point of view, it doesn't stand because we're talking about energy efficient buildings.
Yeah.
Then I understand that, especially we are from a Canadian firm. We know that in Canada they do a lot of electric vehicles that are rechargeable in the building sites. It's always a possibility. It's really a means of priority, I think.
So is it within the scope, or is it considered within the scope?
It's renewable energy. It's not energy efficiency. It's at the top of the bottom. First you need to reduce the demand of the building. Then you apply energy efficient equipment within the building. Then you think about renewable energy and how to use this energy. But it can be to plug a car, which is nice, but it's not the priority when we talk about energy efficiency. The priority is to reduce the energy consumption of the building.
Okay, all right. Thank you.
اوكي، في حدا بيسأل سؤال غير كريم؟ أي استفسار ممكن تكتبوا، إذا ما بتقدروا تحكوا ممكن تكتبوا وإحنا نسأل السؤال. Okay, I think everything is clear. No one is asking questions. Okay. Thank you, Amandine and Julia. I think no one has a question.
Yeah, I really like to thank you again, you and the Green Building Council, and Wijdan if for all the organization. I think we have one question.
We have a question from
Hassan. What about private building?
What do you mean private building? Household or?
New building houses for our clients, for example.
It's the same concepts. I mean, this is applicable for any kind of building. Those are principles of construction in an efficient way. So it can be definitely there are several methodologies implemented in the all parts of a construction that can be applied in any kind of building.
Well, actually, what I mean about how can you actually provide them with a fund, for example, as you have mentioned from the beginning, there are banks and something else. What you as a SUNREF provide for private buildings?
So SUNREF, as I told you at the beginning, is focused on private on private stakeholders. The loan is for private, and if you implement a project that is energy efficient in a private building, it's applicable, it's eligible under SUNREF.
Will them with the building itself, for the construction of the buildings from the beginning, as Ms. Julia has mentioned, that the building itself, the building itself, it should be actually
what SUNREF,
isolated.
Yeah, I get you. What SUNREF could take, it's like the part of the loan that is related to energy efficiency, not the construction like of the thing, but if you put a more insulation or better window, the incremental cost of it could go under the SUNREF loan, but only the incremental costs, not the full costs, because it would be too much, I think. But just send us information and we will see. But do not forget that it has to go through Bank of Palestine and K. Roman Bank.
Thank you.
I think the best way, if we want to talk about a loan, if you want to talk about if it's eligible or not, contact us directly at Econolair. It's not a problem. But then regarding the loan, it's we cannot do anything. The loan are designed and defined by the bank, so it's better to go directly to the bank. So I remind you, it's Karaman Bank and the Bank of Palestine, and they will be able to explain to you the process.
Thank you.
We have Haitham, you can go. هيثم تفضل.
Thank you very much for this useful presentation, Amandine. My question, I have participated in a feasibility study for a solar energy station in Hebron with a company here for a client. And we applied this project for the Arab Islamic Bank. Did you receive this study? Because till now,
Aitam, I'm really sorry. I'm here on the technical side. I'm not. I'm not responsible of analyzing the loan. And it's. I don't know if you receive it. You have to understand that we are trying really to focus on energy efficiency. Okay. I know I'm a little bit repetitive on this, and I'm a little bit frustrating people, but the focus of the new SUNREF is energy efficiency. There will be a threshold at some time that we will stop in a PV system, because PV, it's a widely now technology that is used in Palestine. Many nice projects have been done. SUNREF one pushed a lot. I think the market, and based on what I've seen when I was there and what I hear, the market of PV, it's like it doesn't need more help. I think it's perfectly fine by itself. What we need to push now, it's for energy efficiency. So it's something that I repeated again and again and again, and I'm really sorry for this.
So in the second phase, yeah, you stopped supporting?
No, we do not stop supporting PV. It's just that the focus is on energy efficiency. So we really try to have more energy efficiency project to really focus on the, as we said, the two first part of the pyramid that Julia showed, which is reducing energy demand and optimizing the energy consumption. And we are getting to start nice project. And hopefully, thanks to the Green Building Council, the member will be able to have even more energy efficiency projects. I'm really sorry that it's only dedicated to private, because we received some nice projects from Hebron municipality, but the loan can go only, and even the study fund can go only directed to SMEs mainly. Yeah.
Okay, I send you a message in private, please, if you can't see it.
Yeah, I think the best way is to contact me, because this will stop shortly, is to contact me via email. We will send the Green Council will send you the presentation. We'll share with you. There is our email in the presentation. You can contact us directly, and we will answer any of your questions related, like, for instance, the guideline regarding the monitoring and verification process for contracting that Tuka just asked. It's a very interesting question, but you can send us directly by email all our technical questions concerning SUNREF, and all your questions concerning also energy efficiency in building, and we'll be really happy to answer by email. And also, we are doing some mission in Palestine, so sometimes it can be good to meet directly. We have already partnered with Green Building Council in an event. If I remember, it was, I do not remember when it was. I think it was this summer.
August.
Yeah. Something in August. We might want to do it again if we find, because we are open to any idea from you to push the energy efficiency sector ecosystem in Palestine. because we're struggling a little bit. It's not easy. Everybody think about PV. So any like ideas on how to push the energy efficiency ecosystem in Palestine, it's very welcome. And like the Green Building Council doing this workshop, but any other idea, it's we are very pleased to hear from it and it help to implement anything with you.
Okay, thank you very much.
Okay, we have a question from Tuka. She wrote the question. She says, are there any guidelines regarding the MNV process for performance contracting set by SUNREF?
There is no specifically MNV process. We do not oblige the people to do performance contracting in the project. It's more general project, but if you have performance contracting, it's good. We don't have specific MNV guideline. We would like, if we see a performance contracting project coming, would like to see that they use the international protocol, the IPMVP as a baseline, of course. But we have a verification system at SUNREF to validate that what you propose and the energy savings from the project to release the. It's called the investment grant. It's the subsidy, but mainly that there is no specific. Yeah.
Okay. Anwar.
Thank you very much. I want to ask if there is the program or the project to provide the consultation or advices for how to make energy efficiency for the private or household buildings. And
no, not specifically, because we focused on mainly on more intensive energy consumption. For the residential sector, I was telling you that we will push to have more energy efficient equipment. So the first would be through the refrigerator, but we will not make any like specific like event or something related to the residential sector. We tend to go even a little bit more on the industry sector. We thought that the building sector was very important, mainly on the commercial side, the tertiary side. There is a nice, as you saw in the presentation, option for energy efficiency and with huge energy savings that can be implemented in commercial building. But related to the residential sector, it doesn't mean that it's not eligible. It just means that we will not focus on this because we will focus on the appliances for household, but not on the generic like energy efficiency for household.
Thank you. Just a simple question. Which is the best way or how to get advices for how to make isolation in the new building?
How to make what? Sorry?
Isolation.
Insulation in a new building.
Yeah.
Oh, but it depends. It's two. Each building has its own life. Each building is very different. It depends on the material that you have. It depends on the facade type that you have. It depends, but I think architects are the best one to know which kind of insulation. Maybe Julia, if you want to add something.
Well, I think it depends also on a part of what we have discussed on the design of an energy efficient building. So the orientation and so on. It also depends on what you have available in the market. What is, it can also avoid the import cost and so on. We generally recommend to use local material that are available. I don't know if you have a local production, but anyways, what is available in the market and with the most with the highest coefficient of performance, that is the U coefficient. And yeah, then I think even engineers can orient you on the choice, definitely.
Can I speak? Ashraf. Hi. Thank you, Julia. Thank you, Amanadine. Actually, Julia covered everything. I'm an architect, and we take it in consideration in new buildings. But as you know, construction type in Palestine is different than from Europe, USA, and here we use the concrete, and the concrete is a bad material for insulation.
I agree.
It didn't insulate nothing, no?
No.
So
I agree.
suggest, sorry,
I agree.
I agree with you.
But
So,
it's better for structure also. I mean, so it's not a
Yeah.
so bad element.
yeah,
For insulation, anyways.
Yeah, for
Yeah, for
insulation,
insulation.
that's the best one.
and as you know, it's have a limited years of life. So the life cycle of the concrete is less than the other buildings or steel buildings. And so what I suggest, how we do here, we use to have the skeleton works from concrete, and we use to have a cladding of local stone, which is a good stone,
Yes.
but it didn't insulate the building. So in new technology, we use like Randoban inside the building, and we use the hollow block inside, so we insulate the building.
Perfect.
But we insulate it from inside. The new technology is to insulate the building from outside, to galvanize your building, no? From outside.
The insulation from outside, it's more for buildings that
Yes.
have occupied like more residential building, but sincerely, the insulation from inside, it's good for commercial building because the occupation, it's not like 24 hours. So well, I think
Yeah, but it's better
outside or inside, I think it's good.
Yeah,
Just
the idea,
insulate.
yeah, it's insulated, but it's better to insulate from outside. So the idea here is if we have like to introduce a new building system instead of using the concrete in the country and using different type of cladding outside institute. This is an idea that might be interesting to introduce in the local market here. Because like energy efficiency, we use everything for insulate. We use she covered everything. We use even to heat water from panels. Every house in Palestine heat water from sun, no? So we have it, but the type of building is not easy. And if you in my house, I have the thickness of the wall of 42 centimeters. Because I use that. If we introduce a new system type, like in Europe or in USA, or this might be for the new buildings, I'm saying, a good idea for the market here.
I'm telling you, in France, we use concrete, so it's not, I mean, the materials that you use like as a structure to build, it's independent from the insulation that you can put. Then after we put, of course, a lot of insulation, but the concrete, it's not a bad like materials per se. It's just like something that you need to take into account, calculate your U value of the overall wall, and find the solution. But the solution exists for how you say bricks. Solution exists for wood. Solution exists for concrete. I mean, it's not, and there is many different type of insulation. And I fully agree with Julia when she said what it is available in your market. It might be the easiest one to put.
Yes.
شكرا جزيلا. شكرا. Thank you.
Thank you.
شكرا أخ شرف. شكرا جزيلا.
Okay, any question? I think we all good. We don't have any extra questions. Thank you, everyone. Thank you, Amandine and Julia, for your efforts. And if anyone have an extra questions after the presentation, you can send me an email. I will send you all the contacts for Amandine and Julia and the presentation. So if you have, they can contact you directly, right? Yes, you can contact them anytime. And yeah. Thank you.
Thank you so much. Bye-bye.
Thank you very much. Thank you.
Thank you.
Bye-bye.
Thank
Bye-bye.
you. Bye.
Thank you. Bye.